Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
When I began supercomputing on June 20, 1974, I envisioned a planet-sized global network of computers that was the precursor to the internet. In subsequent years, I invented a new internet that I called a HyperBall that was described in the book titled History of the Internet. I also invented a second new internet that I called a cosmic ball. In the mid-1970s, my new internets remained science fiction. But on the 4th of July of 1989, I constructively reduced that hyperball science fiction to nonfiction. And I did so when I became the first person to experimentally discover that an ensemble of the slowest 65,536 processors in the world can be harnessed to compute faster than the world's fastest supercomputer, and do so while solving the toughest problems in extreme scale computational physics. At its logical core, my technological quest to record the fastest speed in supercomputing and to record it across a new internet, that was my ensemble of 65,536 commodity processors, was indirectly a quest to find the elusive email communication path and to know the unknown communication primitive, that was a quest to find the communication path from each commodity processor to its 16 nearest neighboring commodity processors. My email communication breakthrough occurred when I discovered a new paradigm in email communication, namely how to use a new addressing scheme that was counterintuitive but self-relative. In the old paradigm of computing, supercomputer scientists used an addressing scheme that was intuitive and absolute. With my self-relative addressing scheme, I repeated the email messages that I sent to and received from my 2 to the power 16 commodity processors. With my mathematical discovery of the self-relative addressing scheme, my self-doubt evaporated like dew in the sun. After that mathematical discovery, my confidence soared, and I started seeing myself as the first massively parallel processing supercomputer scientist that could experimentally discover how to make the impossible to compute possible to compute. To the 25,000 vector processing supercomputer scientists of the 1980s that lacked my new knowledge of self-relative addressing scheme, Philip Emeagwali seemed like a lunatic that was pursuing the elusive goal of massively parallel processing across an ensemble of commodity processors that was a global network of 65,536 commodity processors. That was a new internet. I invented a precise minimalist code with email communication primitives that belies its power. My code was so minimalist that my email messages to and from 16-bit long addresses appeared invincible. I wanted my data to be transported from each vertex of the hypercube. That was my metaphor for a commodity processor to its 16 nearest neighboring vertices that had a one-to-one correspondence with 16 nearest neighboring commodity processors. I visualized my emails as flowing quietly and seamlessly across the surface of a hypersphere that was embedded in a 16-dimensional universe, and doing so with the accuracy a cat deploys to tiptoe deftly through a laid dinner table.
Insightful and brilliant lecture.